Hi, today in this video we're going to be talking about exponential growth. So in the past couple of chapters we talked about linear growth. However, exponential growth is useful for data that is pretty much expanding exponentially, right? So if you, like when we're doubling things or when we're doing, like a common example of exponential growth could be population increasing. It's not always going to be linear, because if you have two people and they make like 4 people, then these people make like 4 people, and then each of these people, it's maybe that was a bad example because then they're all, it's a pretty crazy family tree, but basically they're all gonna be like making, it's gonna be increasing like huge, right? So we can't just do a linear growth model. Doesn't really work very well for this. So a common formula that we use is going to be y is equal to our principal times 1 plus our rate to our time or variable that's going to be affected. So principal is the initial amount. Usually it's used in financial terms, where it's say you invest $400, your principal would be that $400. This one is so the principal stays, because if you do just like 3 times like 0.03, it's going to give you less than 1, but we wanted to have 3 times 1 and then plus 3 times like our 0.03 to the t. So that's one of the equations, and we'll just go through some example equations. Problems, sorry. The total attendance at a contemporary art museum is modeled by the function f of x is equal to 18,933 times 1.047 to the x power. If the initial total attendance, that is, the total attendance when x equals 0, was measured January 1st, 2012, what was the initial total attendance? Now it's giving us a hint that x is equal to 0. If you remember, we have 18,933, and then times our number to the 0th, and any number to the 0th is equal to 1. So we have 18.933, and that's actually going to be our answer. It's as simple as that, 933. Growing linearly, the balance owed on your credit card triples from 600 to 1800 in 9 months. Excuse me. If the balance were growing according to the exponential function, f of x is equal to 600 times 1 plus 0.13 x, to the x, where x represents the number of months, what would the balance be after 9 months? Round your answer to the nearest cent. So really all we're doing here is plugging in 9, which I'm not going to do because I don't want to take up too much time. But basically you plug in 9 for x, 600 times 1 plus 0.13 to the 9th, and that will give you your answer. Now, these questions are a little bit more tricky. We aren't dealing with those formulas. It says that our elderly neighbor places a bag of corn kernels on our doorstep each morning. The first day, the bag contained 1 corn kernel. The second day, it contained 2 kernels of corn, and 4 kernels of corn the third day, and so on. So it's doubling each time. Each kernel of corn weighs 0.7 grams. How much will the contents of the bag weigh on the 22nd day? Round your answer to the nearest hundredth. So we know that we're doubling each time. And when we're doubling, we're doing 2 times 2 times 2. And we're starting at 1. And we can't do 1 to the 22nd. Because if we did 1 to the 22nd, it would just be 1, right? So we need to start on the second day. 2 to the 21st, 2 to the 21. So if you remember our exponent rules, we can write it like 2 to the 0th, which is equal to 1. 2 to the 2 is equal to 2. 2 to the 1 is equal to 2. 2 to the 2 is equal to 4, and so on. So but we're already counting this first day, and that's 1. So 1, 2, 3, 4. Basically, we're doing 22 minus 1 because we can't count we've already counted the first day. And 2 to the 21 is going to be a crazy big number. And then we take our 2 to the 21 and times that by 0.07 because each kernel weighs that much. And that will give you the amount. And I'll do that really quick actually, so if you want to try that, you can see. Okay, so I get 14,6,800.64. Sorry, sometimes it's sometimes my brain doesn't have enough power to actually think about what the words are. But that's our answer, and that would be grams. So a lot of kernels of corn. Now this one tricked me. It's the same type of problem, but the issue is, well, we'll get into it. So we create a blog, and after 3 weeks, we get our first subscriber. The wording on these is a little bit frustrating because you don't know if it's saying on the 3rd week or on the 4th week. I believe that it's on the 4th week, but let me just I'll double check with that in a minute. We know that it's quadrupling, so 1 times 4, and then we have ... So we have our 4 to the 0, 4 to the 1, 4 to the 2, and so on. And this is day, week 4. Give me 1 second. Okay, I actually was doing it wrong. I think that it's saying that on the 3rd week, because I know that I did the answer as 4 to the 8th, because I figured that on the 4th week, that is, you have 12 minus 4 weeks left, right? 8. But I think it's saying that on the 3rd week, you get 1. So we'll just do 12 minus 3, which is 9. So we actually want 4 to the 9th. We don't want this 4 to the 8th. Yeah. Which should, I don't know, it'll give you about 200,000 if I remember correctly. This last question is, the water in a pool is evaporating at a rate of 3% per day. If the pool has 19,600 gallons in it today, how many gallons will it have in 11 days? Round your answer to the nearest whole number if necessary. So we have our equation, which is 19,600. That's our principal. That's how much water the pool has in the beginning. And then 1, and then plus, but we're minusing since we're evaporating, 0.03. We want it in decimal form. And then to the time. Then if we plug in 11 for that, you should get 14,019.907. And we need the nearest whole number so we can round this up to 20. Yep. Yeah. I think that covers it for this one. If you have any questions, please let me know, and I'll answer them as soon as possible.